Hi everyone. A hot air balloon is a unique way of transportation. It is made of a large bag or pouch that is filled with air and attached to a basket. When the burners are heated, it allows the hot air balloon to fly up in the sky following the path of the wind.
Basic principle behind hot air balloon physics is the use of hot air to create buoyancy, which generates lift. A hot air balloon consists of a large bag, called an envelope, with a gondola or wicker basket suspended underneath. A burner with power typically of several megawatts sits in the basket and is used to heat the air inside the envelope through an opening. This heat air generates lift by way of a buoyant force.
When the propane burner of a hot air balloon turns on, the flame will rise and heat up the air on the inside. When it becomes buoyant, the balloon will start to rise up. In this situation, the external force will be the buoyant force, causing the hot air balloon not to be in the rest anymore and rise up. The more mass that a hot air balloon has to hold, the slower it will travel. The greater the mass, the more buoyancy force there need to be. I think a hot air balloon can relate to Newton's third law because as the force of buoyancy is acting upwards on the balloon, the force of gravity is acting downward. So guys, next my friend will presenting their physics theory about hot air balloon.
Assalamualaikum and greetings. Today my team and I would like to present about theory of hot air balloon. The members of these groups are Muhammad Zarul Aswad bin Zahari, Muhammad Zakwan bin Anwar, Muhammad Mukrim bin Muhammad Yusli, Muhammad Nur Ajwad bin Halim, Muhammad Al-Bukhari bin Muhammad Amin, Muhammad Syafiq bin Shaizam, and Muhammad Nazwan bin Azman Rahimi. As you may already figure it out, hot air balloon is in basic is just some big bag in which you put heated air, which is produced by some fire source, so it could fly. Hot air balloons were used in the World War II by Japan. They were bombing America. Principle was that they were catching air streams for navigation, and then when they will get to target place, they will just shut down the flame. It is surprising that sometimes they would hit something but they stop because they did not know whether it working or not. About sky lanterns, they were usually made from rice paper and bamboo frame, which balloon was powered by bamboo paper dipped in wax. The principle is that fire heat up the air in the balloon, which creates lift, and then lift is greater than balloon. Balloon weight, then it starts to rise. First great hot air balloon was made by brothers Etienne and Joseph Montgolfier. The balloon was made from paper and powered with burning touch. Volume of 800 cubic meter. It reached height of 2,000 meter and land a couple of kilometers away. Today, hot air balloons are hot air balloons are used in sports. Sky lanterns are used for some special occasions like birthday parties, New Year celebrations, and so on.
Okay, now I will explain the concept physics in hot air balloon. Okay, definition. A ship floats because its weight is balanced by an upward force. The upward force is provided by the water on which the ship floats. The upward force on the upthrust is also commonly known as the buoyant force. In fact, any object, whether floating or submerged, is added on by a buoyant force. In same concept, hot air balloon in the air can be explained using this density concept, such as oil that is always on the water due to its lower density. Since the hot air balloon has a lower density than the surrounding air, it will float above. Density is the mass of volume fraction. The mass of the hot air balloon is the sum of the mass of the balloon and the mass of air inside the balloon. The mass of air in the balloon is the sum of all the air molecules in it. The more air molecules, the greater the mass.
The description of hot air balloon is, since the volume of the hot air balloon is constant, to reduce the density of the hot air balloon, the number of air inside the balloon should be reduced to reduce the mass. And the way to reduce it is to heat it up. The air, when it is heated, will move fast and make the average distance between the molecules going further. This distance, mean distance, causes some air to be pushed out of the balloon. The basic principle behind hot air balloon physics is the use of hot air to create buoyancy, which generates lift. A hot air balloon consists of a large bag called an envelope with a gondola or wicker basket suspended underneath. A burner with power typically of several megawatts sits in the basket and is used to heat the air inside the envelope through an opening. This heated air generates lift by way of a buoyant force.
The hot air inside the envelope is less dense than the surrounding cooler air. This difference in density causes the hot air balloon to be lifted off the ground due to the buoyant force created by the surrounding air. The principle behind this lift is called Archimedes' principle, which stated that any object, regardless of its shape, that is suspended in a fluid is acted upon by an upward buoyant force equal to the weight of the fluid displaced by the object. So, an object floating in water stays buoyant using the same principle as a hot air balloon. The figure below illustrates Archimedes' principle for an object completely submerged in a fluid such as water or air. For the object to remain in an unconditionally stable orientation, the center of mass of the object G must be directly below point C. This means that if the object were to be rotated by any amount, it will automatically rotate back to the original position where point G lies directly below point C. This is what is meant by unconditional stability.
Okay. For a hot air balloon, the upward buoyant force acting on it is equal to the weight or mass of the coolest surrounding air displaced by the hot air balloon. Since the air inside the envelope is heated, it is less than the surrounding air, which means that the buoyant force due to the coolest surrounding air is greater than the weight of the heated air inside the envelope. And for lift to be generated, this buoyant force must exceed the weight of the heated air plus the weight of the envelope plus the weight of the gondola plus the weight of passenger and equipment on board. Okay. As a result, the hot air balloon will experience sufficient buoyant force to completely lift off the ground. As shown in the figure below, the weight of the hot air balloon is more concentrated near the bottom of the balloon at the location of passenger and equipment. So the center of mass G of the hot air balloon is always below the center of buoyancy C. Therefore, the hot balloon is always stable during flight. Okay, now hot air balloon physics, the operation. If the balloon operator wish to lower the hot air balloon, he can either stop firing the burner, which causes the hot air in the envelope to cool, decreasing the buoyant force, or he open a small vent at the top of the balloon envelope via a control line. This releases some of the hot air, which decreases the buoyant force, which also causes the balloon to descend. Second, to maintain a steady altitude, the balloon operator intermittently fire and turn off the burner once he reaches the approximate altitude he wants. This causes the balloon to ascend and descend respectively. This is the only way he can maintain an approximately constant altitude, since maintaining a strictly constant altitude by way of maintaining a net zero buoyant force on the balloon is practically impossible. Okay, and lastly, if the balloon operator wish to move the balloon sideway in a horizontal direction, he must know ahead of time the wind direction, which varies with altitude. So he simply raise or lower the hot air balloon to the altitude corresponding to the wind direction he wants, which is the direction he wants the balloon to go.
The balloon stays inflated because the heated air inside the envelope creates a pressure greater than the surrounding air. However, since the envelope has an opening at the bottom above the location of the burner, the expanding hot air is allowed to escape, preventing a linear pressure differential from developing. This means that the pressure of the heated air inside the balloon ends up being only slightly greater than the cooler surrounding air pressure. An efficient hot air balloon is one that minimizes the weight of the balloon component, such as the envelope, and on-board equipment, such as the burn of the propelled fuel tanks. This term minimizes the required temperature of the air inside the envelope need to generate sufficient buoyant force to generate the minimizing the required air temperature means that you minimize the further energy need to be reducing full hot air balloon physics analysis. The heated air inside the envelope in around the same pressure as the outside air. That with in mind, we can calculate the density of the heated air at a given temperature using the ideal gas law as follows: P equal to rho RT, where P is the absolute pressure of the gas in PA of Pascal. Rho is the density of the gas in kg per m. R is the gas constant in joule per kg. T is the absolute temperature of the gas in Kelvin.
The conclusion is, there are so many different ways through which buoyancy is expressed and seen. As seen before, buoyancy is affected by three different things: gravity, mass, and weight. We saw that an object in air and water is either positively, negatively, or neutrally buoyant. We learned that many different companies have considered buoyancy, like hot air balloon, ship, diver equipment. Also, the buoyancy is acted upon in three different states: floating, sinking, or fully submerged in air and water. Finally, we saw that God, through His creation of an animal, used buoyancy.
Buoyancy is a scientific law that God created to help us understand how things float and to put us in awe of His brilliant creation.